This question asks us to determine if the following are symmetric with respect to the x-axis, symmetric with respect to the y-axis, symmetric with respect to the origin, or none of those, or neither. So let's remember our idea in terms of how we test this. Symmetric with respect to x-axis, you have to replace y with negative y. If it's the same, then check, it is symmetric with respect to the x-axis. For symmetric with respect to the y-axis, you replace x with negative x. I hope you can see why. Try to visualize 2 and negative 2, and they have to have the same equation. If same, check. That's symmetric with respect to the y-axis. And then symmetric with respect to the origin, that's a double fold. Folded over the x-axis, folded over the y-axis, they match. Replace x with negative x and y with negative y. If the same, check, then it's symmetric with respect to the origin. So those are the conditions that we need to define that. Of course, we'll look at graphs to see if that works. So our first question is 4x plus y squared equals 7. Let's check, let's replace x with negative x. Is that the same somehow? 4 times negative x plus y squared equals 7. That's negative 4x plus y squared equals 7. How does that equation compare to the original one? Not the same. Okay, so therefore it is not symmetric with respect to the y-axis. Not symmetric with respect to the y-axis. Let's replace y with negative y. Again, we have 4x plus y squared equals 7. Replace y with negative y. I get 4x plus negative y quantity squared equals 7. Negative y quantity squared, negative y times negative y is positive y squared. That's the same equation as original. Check. So what's my conclusion? That is symmetric with respect to the x-axis. Now we should be able to see that on our graph. So let's jump to Desmos and see what that looks like. Once I get it ready. So I want to graph that and see it. Here we go. So 4x plus y squared equals 7. What does that look like? Do you believe that is symmetric with respect to the x-axis? Here's the y value for negative 1, and here it is also for negative 1, and you can see they're on opposite sides. So if I replace y with negative y, it's the same x value. Y with negative y, the same x value. Notice this is not a function. It certainly is not a function, but it is symmetric with respect to the x-axis. Let's take a look at our next example. We are going to have 2x squared plus y equals x to the 4th over y. Again, I'm going to replace x with negative x first and see what happens. 2 times negative x squared plus y equals negative x to the 4th over y. But negative x times negative x, and negative times a negative is positive. That'll give me 2x squared plus y equals negative x, negative x, negative x, negative x. Negative times a negative is a positive, times a negative is a negative, times a negative is positive. X to the 4th over y. Same equation. Therefore, our conclusion should be that this is symmetric with respect to what? Symmetric with respect to the y-axis. So therefore, the y-axis should be a mirror. So let's graph that and see if that's the case. What do I have? 2x squared plus y equals x to the fourth over y. And what do you think? Do you believe that the y-axis is a mirror? That this point's mirror image is over on that side, this point's mirror image is over on that side? I think so. Is the x-axis a mirror? Not quite. Not quite. It is not. And if we fold it over twice, hopefully you can convince yourself that if we fold it over twice, that also the points are not going to match up. So it is also not symmetric with respect to the origin, but it certainly is symmetric with respect to the y-axis. Also, this is not a function, okay? This is not a function because of the vertical line test. If we draw the vertical line in, let's say at x equals 1, you see it cuts in 2 points here and here, so not a function. But the graph indeed is symmetric with respect to the y-axis. And we have one more thing to look at here. F of x is x cubed minus 7x. So I am using function notation. And you may recall that if a function is odd, it is also symmetric with respect to the origin. But to go ahead and use this strategy, I'm going to rewrite this as y equals x cubed minus 7x. And I know that the one I want to test is replace x with negative x and y with negative y. And we hope we get the same equation back. Replace y with negative y gives me negative y. Replace x with negative x. Negative x cubed minus 7 times negative x. And we get negative y is negative x, negative x, negative x, negative x cubed minus 7 times negative x is plus 7x. So negative y is factoring out a negative here. I get negative x cubed minus 7x. You see how that behaves? Negative x cubed, negative, negative, plus 7x. So if I multiply or divide both sides by negative 1, this becomes y equals x cubed minus 7x. Same. Check. So what is this going to be? If I replace both and it's the same, it is symmetric with respect to the origin. So let's quickly look at the graph and then we'll discuss the odd nature of this function. So we're going to go ahead and look at f of x equals x cubed minus 7x. Does that look odd? Let's adjust our window a little bit. We need a lot more y. Negative 12 to 12 maybe. So can you see if I fold it over the x-axis first and then over the y-axis, the points will meet, the points will match? That's what it means to be symmetric with respect to the origin. So this point here, if you change both of the signs, negative 1.528 and positive 7.128 should be up here on the graph somewhere. There you go. There it is. So that indicates the point that we're looking for there. Now, as I said, if you're symmetric with respect to the origin, your function is odd. So what do we have here? We have f of x is x cubed minus 7x. To determine if the function is odd, replace x with negative x. F of negative x is negative x cubed minus 7 times negative x. F of negative x is negative x cubed plus 7x, which is the same as the negative of x cubed minus 7x, which is the negative of f of x. Since f of negative x equals negative f of x, the function is odd. All odd functions are symmetric with respect to the origin.